Today I'm going to be talking about adding and subtracting fractions, both with and without common denominators. To add and subtract fractions, the numbers, or the denominators, need to be the same. I can show that here with these pictures. Here I've colored 4 out of the 6 red, and now I'm going to add one more sixth. And how many sixths do I have now? Altogether I have 5 sixths. In the second problem, I shaded in 4 of the 6 pieces, and then I'm going to subtract 2 of those 6. To do that in this case, I'm just going to color over them this way. And how many of my original red sixths do I have left? I have 2 of those 6 left, right here. But what happens when you have denominators that are not the same or common to each other? We need to find numbers that allow us to compare them directly. To do that, we need to find numbers that are common to both denominators. First thing I want to do is write these fractions stacked up so that I can see my work better. Then I'm going to look for a denominator that they both have in common. Look at the 3 and the 6. What multiple do they have in common? I would like the least common multiple, or the smallest number, and in this case they're both common multiples to 6. Now I want to show that 6 times what equals 6? 6 times 1. Whatever I do to the denominator, I have to do to the numerator, so 1 times 1 is 1. But how many times does 3 go into 6? That's 2 times. So if I did that to the denominator, I must show the same thing in the numerator. So 1 times 2 is 2. Now I can solve my addition problem. We know the denominator is going to be 6 because that's the common denominator. So 1 plus 2 is 3. Now in this case, we know we have to simplify, and 3/6 is the same as 1/2. If you need a refresher on that, please feel free to watch the video again on simplifying fractions. What about subtraction? The steps are all the same, except that once we have a common fraction or a common denominator for the fraction, we're going to subtract. So first thing we're going to do is write this out in a way that's easier to show our work, and then find fractions that are equal to these so we can get a common denominator. What would be a common multiple for both 16 and 8? They both go into 16 evenly. Now this would be 16 times 1, which means that I'm going to do the numerator times 1 as well. So you can see I'm really just moving 3/16 over. But here 8 times 2 would be 16. That means I'm going to multiply 2 in the numerator as well. 5 times 2 is 10. Bring over my subtraction. And now 10 minus 3 is 7. And of course the denominator is going to stay 16. So the answer to 5/8 minus 3/16 is 7/16. Why don't you go ahead and copy this problem down and try and solve it, hit pause, and come back and see how I solved it. First thing, I'm going to write this vertically so I can see the problem a little bit more easily and show my work. What was the common denominator you got for both 10 and 5? Well, they're both multiples of 10. 5 times 2 is 10. That means the numerator will be times 2. 1 times 2 is 2. And again, I'm just going to bring this over because I know it's times 1. So let's bring the problem over. 7 plus 2 is 9. Denominator is 10. Did you get 9/10? Great job. Copy this one down, hit pause, solve it yourself, and then come back and watch. I'm going to copy this down. So I have 1/3 minus 1/5. I need a common denominator. Now this one was a little bit stinkier. Did you figure this one out? 3 and 5 do not have a common multiple. In other words, 3 doesn't go into 5, where the other ones were going into each other. So in this case, the common multiple is going to be 15 for both of them. And so I need to multiply this denominator by 3, which means this numerator by 3. And here I need to multiply the denominator by 5, so the numerator by 5. And now I'm going to bring my subtraction sign over. 5 minus 3 is 2 with the common denominator of 15. Did you get 2/15? Did that make sense? In this case, in both cases, we had to show multiplying the denominator and numerator by numbers. Go ahead and try this problem on your own. Come back and see how I solved it. I'm going to rewrite the problem. 9/16 plus 2/8. I need a common denominator for both of them. In this case, I'm going to say, well, 8 does go into 16, so I'm just going to bring over my 9 and 16. That would be times 2. Times 2 is 4. We're doing addition. So 9 plus 4 is 13/16. This is the last one you're going to try on your own. Go ahead and give it a try, and then come back after you hit pause. 6/7 minus 2/3. Well, this is one where we're going to have to find a denominator for both of them because 3 does not go evenly into 7, but they do both go into 21. So 3 times 7 is 21, which means I'm going to do this times 7, which is 14. And 7 times 3 is 21, so 6 times 3 is 18. This was a subtraction problem. So 18 minus 14 is 4, and the denominator is 21. How'd you do? Go back and look at any of these if they seem tricky. All right, you know you need to get a piece of paper, notebook paper, turn the page sideways, please, mark off the 4 quadrants, copy these problems down, solve them, and bring them into school with you tomorrow. I'm going to go ahead and call this A, which means I'm going to give you a harder set to do B on the next page. Your choice. I don't care if you do A or B. Feel free to do both if you'd like to try them. Either way, finish up 4 of them and bring them in with you. Can't wait to see you tomorrow. Now, these are a challenge for many reasons, some of which include that they're improper fractions where the numerator is larger than the denominator. If that's the case, then I want you to switch it back into a mixed fraction. So try this if you want. If it's too hard, don't worry about it. Go back to A. But if you want a nice challenge, remember that if you have an improper fraction where the numerator is larger than the denominator, you need to put that into a mixed number with a whole number and a proper fraction. Good luck. See you tomorrow.